So, just a little review. So we've got test threes passed back. I do have them in my office. If you didn't get yours back yet, we can get them there. But overall, I haven't looked. I mean, just as I was grading it, it seemed like people were doing better, which is good. Remember, even if you didn't maybe do as well as you wanted, if you made some progress on it, remember this sort of part is hopefully helping to connect everything else. So as you go back and start reviewing test 1, test 2, and test 3, you can do strongly on the final. And that gives me more data to work with. If you do really well on the final, there's a lot more I can do. I can see the progress. And especially if you've been kind of upping it a little bit each time. So anyway, definitely do the best you can with that. I still have a lot of test 2s and test 1s. They're all in my drawer. So if you come and you haven't gotten one of those, just ask me. I'll get them. If you let me know in advance that you're coming to class and you would like it, send me an email. I'll pull them out of my drawer and I'll bring them. But then please do come to class, because otherwise you won't pick them up. And sometimes I leave them at home or something because I take them home with me. And then it's harder to get to you. But anyway, I want you to have all 3 copies of the exams that you've taken so you can see how you did. I have also posted, well, before I go there, so Tuesday we did average value, which was really nothing new. Remember, we go from A to B of some function. We're integrating some function. And all it is we added that if they ask for the average value, we do the same thing. We've done this before, taking the integral of a function, except we multiply it by 1 over a minus b. A minus b is the length of the interval, so that's giving us an average value. That's all that was new. So really no new technique. It's just say, if they ask for average, multiply by 1 over a minus b, the length of the interval. Today is kind of a similar type thing. It's a business application, but it directly relates to the area between 2 curves, which was on the last exam. So the concept stuff, the skill stuff we need to do for calculus is no different than what we've done before, except it's going to look like a formula, but if you can kind of draw it out, it's just area between 2 curves. So we're going to explain it that way. So again, the calculus concept is not new. It's just sort of a new application. And so I'll focus a little bit more on the business applications. And then just to kind of see what we're doing on Tuesday, because we're getting into that, it's going to be real tight. Basically the next week we're having the final right on Thursday. Improper integrals is the top integral or the bottom integral goes to either, top integral goes to positive infinity, or the bottom integral goes to negative infinity. Mostly it's going to be the top one goes to positive infinity. What we use that in business is if you want to see the accumulation, but you have an unknown, you don't know how long the business is going to go. So it's indeterminate. So you just do it forever. Okay. So it'll be a brief implication of it. Hopefully I'll have the final by then. I can see if there's any questions that even deal with it. Sometimes there's only like 1 question on that new material. So I'm not going to I don't want us spending a lot of energy on one little thing, one new thing that might seem like a lot for just 1 question. I want you to start reviewing stuff. So I'll take a look at it and see what it looks like, and we'll focus our attention on sort of what they might test on it. If I find out that there's no question on the final from that, we'll boot it, and if you want to do it, we'll call it extra credit. But if we do need it, we'll make sure we cover it. Okay. So I'll let you know that Tuesday. Okay. And so again, this is what we're doing here is really going to be area between 2 curves. So we just, and there's 2 applications. What basically happens is one's on top for one application, and then it sort of switches. So it's about demand functions and price functions. And whether you're a consumer or a producer, the surplus happens in the opposite way. So it's just a matter of remembering which curve is going to be on top. But we'll talk through the business application of it, and hopefully that will make pretty good sense. We'll also have the formulas for it. So it really is just, going from, actually we usually go from 0. We're going to see that this goes to Q, which is the average demand. And then you'll have two functions, specialized functions. And we'll see. So it's really just this thing of two functions. Which one's on top goes first, the one on bottom goes second. So we're getting the area between two curves. That's the application. And we'll look at, there's some details, some business details we have to do to figure this out. All right. Let's delete that. And we'll actually look at one of the last homework assignment, kind of puts it all together, and we'll work through it together. So that was that. What I did is, I didn't change the name. So this thing that says cam scanner, yeah, is just, I took pictures of my solutions for the test. So if you go here, you'll see how I work through things. So if you have questions about, why you didn't get points on something, you can compare it here. And again, it's on some of these, it's whether if you got partial credit of 1-1 instead of 2 points, it's a little bit luck of the draw. It's kind of and so I can be easily persuaded, especially if you bring chocolate. No, you don't have to do that. But I can be persuaded if you think you should get a few more points.
Do you have that for the last two exams?
I do. I believe. Okay. I think I do. So I know I had it for the second exam, and so that should always appear in the bottom. So this was for test number 3, review test number 2. Let's see. It should be exam 2 solutions. And I know I did it here. I can't remember if I did it for 1 or not. I think I did, but let's just check. Because if I did not, I will upload it. And then test 1 was kind of all one thing. So if you open that up, yeah. So I did do solutions for, and so that's, even if you don't have yours back or something, that this is a good way to go back and review the previous exams. Sometimes I circle the right answer, but I have a little bit here, but it gives you an idea of what's going to be on there. Someone asked me about what's the length. Our exams have averaging, they've been 12 questions, right? But with some multiple parts. I would assume the final will be closer to probably 20 questions with about the same breakdown, maybe 10 multiple choice with 8 open answers, something like that. But not too much, so it's got to be long enough so that they can get some questions from exams 1, 2, and 3 in there. So as I find out more, I'll let you know more, but it's good to go back, review these 3 again. So you figure, let's put 21 because that's easy to divide by 3. There's maybe 7 questions from each test, probably 6, probably 5, because it might be 1 or 2 from the new stuff. Questions? Okay. So that's that. And again, if you have any questions as you're going through things, need anything, just let me know. If it's already in Canvas, I can send you the link to where directly certain videos are or certain resources, or you might ask for something that's not there. I can scramble and make them available. Okay, so we're looking at applications of business economics. So this is going to be consumer and producer surplus. Okay, so how many people we have in here that are in economics? Okay, good. Wow, almost this whole side. So you're going to be helpful. Okay, this should be something that resonates very well with you. Okay, consumer surplus. So what this is based on is that typically when you bring out a new product, it's going to have a higher price because you need to. You don't have people haven't bought it yet. So it typically will have some starting price, which is a little high, and not too many people are going to buy it. The early adopters will, that have money to burn, but the rest of us poor suckers can't afford it yet, right? So we wait till the next thing comes out, or until enough of them have sold that they say, okay, we can now, our production is up and running, we're making more of them, so we can, economy of scales, we can reduce the price. And so that's the kind of thing, as the price gets reduced, so prices along the y-axis, as the price is reduced, more people are willing to buy. So Q is the demand. The demand is actually going up as the price goes down. Does that make sense? And I'm usually the guy that buys either halfway through or usually more towards the end. Once it gets cheap enough, I'll buy it. It's like when the cell phones came out. I bought one of those brick ones like 5 years after, when they start getting the little flip phones. I bought the bigger ones, but so anyway, that's what's happening. So the idea of this whole thing, though, is sometimes producers will say, hey, if I start off with an artificially low, we should be charging more because of our costs and everything, but what if we start with a lower price and get more people buying sooner, right? What would that do? So that's what this is about, is if we start at a lower price than what demand would say the early adopters are willing to pay, we're going to get more people buying sooner. So that's what this is about. It's pretty wordy, but typically what they're going to do is they're going to pick some average, what is the average demand from start to end. So if the function says it goes down to here, what if we put the price at about the average price for the average demand? Okay, so that's going to mean that we start with a lower price, but we're going to get bigger demand right off the bat. And sometimes that helps, because in marketing you start, everybody starts loving it, and you actually possibly make better revenue. Okay, so let's see what this looks like. So first of all, we're going to talk about, if we don't do that yet, for the full price, what do we get? So just remember, this is kind of you don't have to do this, but this is from Riemann sums. So they said a way to get an estimate is to draw in all these little rectangles, however many rectangles. Now notice this is going to give us an over estimation. So this would go in here, right? And then there would be one from here to here. So there's our rectangles to do a Riemann sum, right? So that's what all this thing is about. Don't worry about the formula for this stuff, because we're not going to have you do Riemann sums. This is just getting, hey, remember we did Riemann sums, so we're going to show you about that. And this is the formula for Riemann sums. Notice we're adding each rectangle in there. Again, don't worry about that. That's not the lesson. What it is if we were to just integrate it, because this is like an infinite number of rectangles, we'd get the actual value, right? So this is saying, if they follow the demand function and the pricing scheme from the demand function, that they follow this curve, this green is what? What does this green, in a business sense, or economics, what does that represent? Remember, it's price times demand, and the demand is the number sold. So it's number sold times price. That gives us very important business concept of revenue. That's our revenue. It's not profit, because we haven't subtracted the cost, but this is our revenue. This is the company's revenue. It's also kind of, in the setting, it's the maximum that consumers are willing to pay. We're getting the maximum money out of the economy, because we took, the early adopters would pay more, so we took all that money as the company. We lowered the price, not because we were nice guys, but because nobody else would buy it until we lowered the price. So we lower it because that's what the demand said. We wouldn't sell anymore unless we lowered that price. So we kept lowering the price to sell more and more until we saturated the market. And then now nobody else is going to buy it because everybody's got the latest, right? Okay, but so we've kind of maximized our revenue. We've pulled the most money out of the economy that we could. But what if we were I don't know, nice. And usually it's not about being nice, it's about a business plan that actually, we're going to look like we're nice, but we're going to get more out of this. And so what we're going to do, instead of following the price, charging the maximum price that the market will allow, we're going to start at a lower price, and we'll call that P bar, which is the average price that from the average demand. So we use the functions to figure what would be the average demand. So that kind of like what we did on Thursday. We're not, and for the problems, they're going to give it to you for the most part. Okay, there's one we're going to have to calculate, but all the other problems will say this is the average demand. So you could calculate the average price, and this is how it's going to work. But notice what we've got is we've got less revenue than we had on the previous slide, right? That's a lot of revenue. We're losing some revenue as a company. We lost all this white space up here, right? Well, where did that money go if we didn't get it? Where did it come from when we did get it? Come from the consumers. We were taking it out of people's pockets. We're leaving it in their pockets. So this is now a consumer surplus. The benefit to the economy is consumers, they're satisfied. We saturated pretty quick. We made a good profit, we made a good revenue. Hopefully we made a good profit as well. But we left money in the economy so people could still have some disposable income, that they were willing to pay for it, right? So this is our consumer surplus. Notice it is the area, it's not the green area, the green is the revenue we got, and we could calculate that, but the questions are going to ask us to calculate this consumer surplus. Notice it's the area between the demand curve, D of Q equals P, and this function, the average price. Okay, so when we put in, and we can always get the average price because of the way the function works. If we put in the average demand, which they will give us, we put that into the formula that they give us, and what we end up with is the average price. So there's going to be ways, and we'll work through a couple examples, or at least one example. You'll see how it works, okay? And then when we have that, that's a constant, right? It's a horizontal line. And so we're going to see how that makes that formula. It's really just, right, DQ's on top. So we're going to be given that function. We subtract the bottom function, which is P bar. So that's, right, that's the area between two curves. And it's DQ because we're integrating in terms of Q. Wait, DQ is a product. Is this DQ or DP? I get myself, it might be DP. We'll look on the next slide, but, it's down here. It's DQ, okay? And what we're doing is we're integrating from 0, because that's the X here, until Q bar, okay? DQ. Answered my own question by just reading. Sometimes it helps to read. Forget to do that sometimes, okay? So that's the formula that they're going to show on the next slide in a little bit more detail. But that's the formula for consumer surplus, right? They're going to give us the function, D of Q, some like P squared plus this or what. So we're going to get that. We integrate it, and then we subtract P, the average price, which is a number that we're going to calculate. We integrate that, and we take it from 0 to Q bar, which is a number they're going to give us. That gives us our consumer surplus. That's the amount of money we leave in the economy when we charge a lower price, an average price, to kind of pick up more sales at the beginning. And what that helps is we can hire a sales force and there's going to be a lot of sales right from the start. Whereas if we charge a lot, we get all this sales force and training and there's not many sales and people say, oh, I'm not getting any commission, so they leave after we trained them, right? But if we get a robust sales stuff, our salespeople are getting commission, we're selling a lot of stuff, we're able to produce more early on, and we're leaving money in the economy, so we could come out with some accessories that somebody will be willing to buy. It's a win-win situation. Okay, so business is not about always maximizing your profit from day one. Sometimes you have a plan, let's leave some money in there so that can fund some other things. And it can also ensure business success, because it's a lot to get a sales force trained on a product, and you want them to be successful, and you're only going to keep the best sellers if they're actually able to sell and make commission. Otherwise they'll jump to another company where they could sell more. I know, I've worked in sales. I didn't jump, but I know people who, they go to the next thing, right? Does that make sense? So let's, here's the explanation. Okay, so you could look at this as two things. This part is graphically the first graph. It's all the revenue we talked about. So they calculate all the revenue and then they subtract off the rectangle of the reduced revenue we would get if we had it at a lower price. And then you get surplus. The way we're going to calculate it, though, is we'll use this other, which they're equal to each other, right? So this is using geometry. This is kind of using calculus with the area between two curves. Okay, so these are the same thing. I spent a little time trying to figure out the algebra of how they got from this one to this one, and I realized it's not algebra, it's just that they're equivalent, but they're two different ways. So this first one, what they did is physically, they calculated this area, and then they subtracted this green box, and that left the part on top. The second formula that we came up with, we'll just calculate this directly. So it's one calculation, and we're done. So we're going to focus on using this. We could use either one you want to, but you'll see that this is going to be sort of the easier way to go. Okay, so we'll go through an example of how we get all these little pieces. So far, so good? Understandable? Okay, and good. Producer surplus is just the sort of the opposite. Same type of concept. We could produce more, but what we do is we do the same thing, then the producer has a surplus. The cool part is that average price, if we can match that, we could have, it's weird. You actually give a surplus to the consumer and the producer. You're leaving more and more money in the economy, and that's where you can get some really good growth. If you don't do that, you're sucking all the money out of the economy. And again, at places like where we're at, where we're trying to get the economy going again, or at least some of us are. I don't know about our Fed is seeming to wanting to slow it down, because it does create a little bit of inflation. But if we want to get it going again, this kind of thing of trying to keep prices down is actually a good thing. It makes inflation look like it's not so much. We can keep things going. And the thing is it leaves money both in the consumer's pocket and the producer's pocket. So then there's more money for both to spend. Okay, so this formula, what it's going to get us is this area, which is not revenue really. It's the revenue we didn't get, the company didn't get, but that we left in the pockets of the consumers, so they could buy other stuff. Hopefully, keep the economy going, right? Go on vacation, whatever. Okay, so how do we get this? So here's an example. Well, we start off with a function, a demand function, which is usually set up that at a particular price, this is the demand. So Q is equal to the number of items sold, number sold. P is equal to price. Okay, so they give us some sort of relationship such as this. Q represents daily sales of used DVDs. Could be annual sales, whatever they give us, but in this case they're telling us it's daily sales. P is the price you charge per DVD. Okay. Calculate the daily consumer's surplus if you sell your used DVDs at $5 each. Okay. So what you could kind of see is if you put in like a higher price, you would sell fewer, right? So what they're saying here is that we're going to go with sort of an average price of $5. And, you know, notice this function, this is where we're plugging in Q. So this P is really DQ. So that's going to be what we integrate. And remember, to find all of this, what we're going to do is we're going, and they'll walk us through step by step, but I'll kind of just think through here. We want to figure out, again, not the revenue, but this is the surplus left behind. So we're going to integrate from 0 until Q bar. I'll write out in details. And Q bar is 5, right? So we're going to actually replace that with a number. We're going to integrate the function d of q, the demand function, which is 15e to the, is this up here. And then we're going to subtract p bar, dq. Okay. What we're going to see is p bar is a number, which we're going to get. Q bar is a number, which they gave us. So let's just kind of set this up. So this is the easy part. We're going to go from 0 to 5 because they told us Q bar is $5. Okay, they'll give you that. DQ is the function 15e to the minus 0.01 Q. And Q is just a variable. So and we're going to integrate that. And then we're going to figure it out. Minus P bar, right? How do you think we get P bar? The average price. We got Q bar, right? Remember, P bar goes with Q bar. So what we're going to do is we're going to plug Q bar into the function. So P bar is equal to 15 e to the minus 0.01 Q bar, which is 5. We just plug it in. And now we need our calculator. That's what I like about this. It's just kind of, if you think through it, you can kind of get the values, and then it's not as abstract. So this is, what is this doing? There we go. Okay, so I'm just going to type in 15 e to the minus 0.01. So that's a 1%. That, so as price goes down, I guess demand drop. As you drop the, it's a drop. I guess if you drop the by 1%, it's a 1% drop, right? E to the minus 0.01. I'm not sure what it's dropping by. Times 5. It's all up there. If you do that, I get, just putting this in my calculator, and I apologize for not being able to do it on the screen, but I get 14.26. Did anyone else? 8.4. I'm just going to go out because I don't want to get rounding errors, so I go out probably 4 decimal places will be. So, and again, remember this is a price, so it really only makes sense to have 2 decimal places, $14.26, 27 cents if I round it up. But if I go out a little bit further, then I can round at the end. Does that make sense? Anyone do this? Check me on this. It worked. Okay, good. So that's going in for P bar, which is here, 14.2684 DQ. Okay, and now this is just we've got the formula. We've got our limits going from 0 to 5. And we don't have any space, but so this first part is the hardest part to integrate, right? This is e to the minus 0.01 q, or x if you want to. You can think of that. That's our variable. So this first part simply, it's going to be 15 e to the minus 0.01 q, and then this number in front, this minus 0.01 minus 0.01, we have to divide by that, right? When we're integrating. That's just sort of the rule. If it was a to the x, a to the x, remember shortcut rule, integrating a to the x gives us a to the x divided by a. Okay, so whatever that little a, that number in front, and in this case, a is 0.01. Okay, this is acting like the a. So we divide by it. And then when we integrate 14.2684, that's a number, it's a constant. When we integrate it, it's just going to be minus 14.2684 times q, right? So it's just the number q. And then we plug in 0, 5 and 0, right? So what we're going to do is, again, we kind of ran out of room, so I'm going to show you from here. We would plug in 5 for q here, 5 for q there. We get a number, and then we'd plug in 0 for q, 0 for q here. We'd get another number, and we would subtract the two, right? So just the basic, once we integrate something, it's the function at 5 minus the function at 0. And this is the integrated function. Okay, right? We integrated f of x dx. So once we integrate, we just take those two. So let's walk through and watch the rest, because it's going to get a little bit messy, but I'll just show you. So, oh, these disappeared. I thought I moved them earlier. So this should be, by definition, d of q bar equals p bar. Okay. Wait a minute. Did I do this backwards? I'm glad I looked at that. I did 5 as if it was a demand, as if it was a Q. But notice this is the price. So we're going to back up a little bit. Let's watch this. So there should also be a Q here. So what they're telling us is that P bar equals 5. And my last one, I made the mistake of calling it Q bar. But it was actually, if the price is $5, that's price, right? That's the average price. We need to get the Q that goes with that. So we got a lot more room here. So we could solve this graphically. You could graph this as y1, this is y2, and find the intersection. So how much demand do we have at $5? Apologize for taking you on a wild goose chase, plugging in the wrong one, but that's the hardest thing sometimes in these things, right? Pay attention. Okay, so we're going to solve for Q bar, so I'll let them do it since they're probably doing better than I am. So if you take Q equals Q bar. So you divide, I think this also messed up a bit. So to get Q bar, we divided both sides by 15, right? There was this side over here, the P bar we're looking for is, and I think this is wrong, it should be P bar. This is 5. You take 15 divided by 5, or sorry, 5 divided by 15, right? You're going to get your 1/3. So they had a 15 over here. So we're getting closer. We want to find out what Q bar is. We take the natural log of both sides. Natural log of E is 1, so this all comes down. Natural log of 1/3 is natural log of 1/3. And then we're just, to get Q bar, we just divide by negative 0.01. And we get, when we do that, that becomes the natural log of negative natural log of 3. Okay. So, forgetting what I said before, the integral is going to go from 0 I think what the way they got that is, okay, we can see where the negative comes from. If you take the reciprocal this is 0, so you get negative natural log of 3. Let's see. Oh wait. Yeah, they're leaving some things behind. So negative natural log of 3. It's the first time I've had problems with the PowerPoint losing stuff. So Q bar is equal to natural log of 3 over, so the negatives canceled out, which gives us that the demand is, at that price we should sell about 109, 110 if you round up. Okay, so they'll give us the price, which is the answer to the function. We have to solve for Q, so that's the first issue. And then now we'll be able to go from 0 to 109.86. And remember, our function is going to be 15 e to the minus 0.01 q minus 5 in this case. Okay, because that's p bar. And they're going to show us that. They fill in the blanks, right? So actually, this actually ends up looking a little nicer than what I had originally because I put the 5 in the wrong place. Put it in for Q, not for P. So this integrates. This is going to be 5Q, right? 5Q. This just becomes its own integral, but remember, this is like that value of a, e to the ax. When we integrate it, it's going to be e to the ax divided by a. So we can see that's all that's happening here. And then we go from 0 to 109. Okay, and remember that this is what we had to calculate because they'll give us the P, they'll give us the price. And that's typically what you would do, is you would set a price and then you'd be able to determine the demand, how many you would sell based on previous. And so then, again, what you do is you put in the 109.86 for both of these, you put in 0 for both of these, and what you do is you get, when you put 0 here, this ends up being 500. When you put in, when you put 109 here, we end up with negative 500. When you put 109 here, you get 549. So we get this number. And then when you put zeros in, you get the, this is at 0, 5 times 0 is 0. You got this negative coming through. So when you do all the arithmetic, this gives you about 1,049. This gives you plus 1,500. So it would give us $450.69. Again, what is that? that is the consumer surplus. It's not our revenue, it's what we left in the economy. If we would have followed the demand curve, that could have been money we made. So we are actually giving it up. But we have an alternative move. We've actually also sold more. We've actually sold the same number, I guess, as if we would have followed that curve. But we left some money in there, so maybe we'll have more sales next week. Right? Because there's some people who have some money left in their pocket. Maybe they bought more. That's what we're hoping. Sorry about that. Did that make sense? Okay, just make sure you get your P's and Q's lined up. When they give you the P, put it in for P. Okay, so we'll do the same thing, but now we're going to do with producer surplus. So this is the same concept, but looking from the side of the producer. So the producer's demand curve looks a little different. It's how much. So for the producer, if the price goes up, they're willing to make more. Hey, they're selling. There's if you're a farmer and the prices are down, hey, I'm going to wait till next year. I'm not going to plant anything because I'm not going to make much money on my peanuts or whatever I'm selling. But if the price goes up, I'm going to plant some extra fields, right? I'm going to produce more because I can get a higher price for what I'm getting. So this is the curve for the producers. The more price you offer, the more we're actually going to produce. And hopefully, and again, it's determined on statistics of how much I could sell. Okay. So what we're going to see here, though, is if we sell it at a lower price, what we end up doing is this is the lowest price we would have sold it at. Following along here, we're going to supply more. So what happens for producer surplus, this is the lowest price we're willing to sell at or produce anything. But if we sort of take the average of the demand and we charge the average price, so we average everything out, say, okay, over this much time we're going to do, what ends up happening is that we actually start the price at a higher level than the lowest level the producers are willing to produce at. So in this case, the average price is actually higher than the lowest price we were. And a lot of times we're willing to produce, a producer's willing to produce as long as they can break even. That might be break even. But if you can get more, we can make more profit. Oh, we'll make more then, right? At a higher price, we'll make more. And so that's what's happening here, is they make more and sell more, and they started getting the higher price at day one. So this green now is extra revenue to the producer, because basically consumers are willing to offer them an average price, a higher price to start off with, so that there's enough production. Okay, so and again, and the reason it's maybe in the benefit of consumers, maybe it's a hot product, and if we started off at a lower price, it would take longer time for them to produce enough to fill the need. Okay, so looking at averages, again, we get the same thing. Notice, though, when we think of this as area between two curves, in this case, average P is on top, so that goes first. The suppliers or producers' demand function goes second, because it's on the bottom, because typically it's going to have a positive slope to it. So that's the only difference. It's really going to follow the same sort of thing. We're going to set a price, set a P. We'll have to solve for Q. We're still going from 0 to Q, because that's the interval. But notice this will give us our producer surplus. Okay, so let's look at this example. We're selling, we have tie-dye t-shirts. We'll produce enough to fill the orders. I have informed one group that I'm prepared to supply this many t-shirts at a price of $P. So what if the shirts are priced at $8 each? So that's kind of like that becomes the P bar. Okay, so what we need to do is we need to find Q, but notice this time our function is set up that they're giving us Q in terms of P. So it's actually going to be a little bit easier if they do it this way, because we can just plug in our value here, right? So let's walk through this. So this, what they did first is to kind of, I don't know if you needed to, but they squared both sides so we don't have a square root here to make the numbers maybe a little bit better. Again, you don't necessarily need to do that, but they went ahead and did that to solve for Q. P is a function of Q, so they're going to solve for P because that's, remember, we want S of Q, which means we have to plug in Q to get P. So they square both sides and then divide by 400, add 4, or we will get there. So we squared both sides, you got Q squared. So this is our producer's function. And again, if they give it to you in terms of P, you just have to solve it for, or sorry, if they give it to you Q equals, we need to solve for P so that we have the producer surplus. With that being said, we also need to find out what Q is, what the Q bar. Actually, if we use this function up here, that's probably going to be a little bit easier, right? We could plug in 8 here. 8 minus 4 is 4. Square root of 4 is 2. 20 times 2 20 times 2, we should have that Q bar is going to be equal to 40. And that will probably come on that. Now you could probably do the same thing here. That when P equals 8, Q has to equal 40 for this all to work. Okay, so they do this, just what we did. They plug in the 8 for P, so they can solve for Q 40. Okay, just like we did. They're going to put all the pieces together, so now we've got our Q bar, so we're going to go up to 40. Right, there's our Q bar. P bar is 8. They gave us that. We just plugged that in. We figured out our function in terms of Q, so that was the hardest part of this. And then now we just integrate. We may want to distribute this and get 8 minus 4, which they did. So this gets distributed. So 8 minus 4 is 4. Kind of. So we just integrate two things. When we integrate 4, what do we get? We should get 4Q. When we integrate Q squared, what do we get? We're going to get minus Q to the third. It's already divided by 400. So we're going to multiply, we're going to divide by 3 as well. So actually we're going to divide by a total of 1200. And then we're going to take that from 0 to 40. And that's just going to be a calculation, right? So 0 to 40, they did all the details for us. When you plug in, notice when we plug in 0, we get 0, so we don't have to worry. So you really only just plug in the 40. 40 times 4 is 160. And then 40 in here, do the calculation, we end up with 106. So that's $106 is the surplus. So we'll actually, that's a surplus that the seller gets selling it at $8. Because I was willing to sell it at lower dollars, initially at least, but I'd only sell a few of them. If I was going to sell more, I would raise the price as I go. So this is, oh, we're going to start out at $8, so I'll make more shirts. Okay. And again, sometimes that the producer is willing to maybe make them at cost initially, but they're only going to sell a few at that. So they start at a higher price, they actually make more. Concert goers or whoever's buying those t-shirts are a little bit more satisfied because they have more product. Because, you know, as the night goes on, you can't make more shirts, right? He's got to know a price. That's how many I'm willing to make, because I'll, you know, maybe it costs them $4 to make it, so he's willing to do it at that price. Does that make sense? Okay, so we've got two things going on. First, for the consumer side, if we start with a lower price, we'll actually leave some consumer surplus, because those early adopters who are willing to pay more, that money gets left in their pocket. Okay, so that's a concept of consumer surplus. Producer surplus, we're able to charge a higher price than their minimum that they would take initially, and that means that will produce more, having more willing to sell. They will actually have more revenue. Okay. What we're going to do is, this is the last question in the homework, and it kind of does both sides of the thing, looking both at the consumer and the producer. So this is a setting that a college will charge a certain tuition, and at that tuition rate, they're willing to accept a certain number of students. So our demand is how many students are willing, you know, in there. On the consumer side, students are shopping, and at a certain tuition, a certain number of students are willing to go to this college, right? And so what we're going to try to do is find an equilibrium price where the number of students that are willing to go at a given price will match the number of students a college is willing to accept. So if we get that price just right, then it's perfect. We got the number of students are willing to apply, the number of students the college is willing to accept is matched. So it matches a surplus. Well, and again, this is all based on marketing research. That's how they get these formulas. Are these formulas always right? No, because they're based on previous marketing and stuff, right? Things change. But if it is, so here, a study of a country's colleges and universities result in a demand equation. Q is equal to 20,000 minus 2P, where Q is enrollment at a public college or university, and P is the average annual tuition plus fees that it charges. So at a particular price, this price will produce this many students. And so that's from the consumer side, right? At this price, this is how many students are willing to go to that college. Officials at enormous state university have developed a policy whereby the number of students it will accept per year at a tuition level of P dollars is given by this function. And notice in both cases, these are Q. So this is on the producer side. We'll accept this many students with the tuition rate of this. Find the equilibrium tuition price P bar and the consumer's producer's surplus at this tuition. So we've done the producer's surplus and the consumer's surplus. The one thing we haven't done is this equilibrium price. So I'm going to work it with this one. Now you'll notice when you get this question, the number 6,000 may be different, quite, because that's a randomized event. But to find the equilibrium, what we want to do is we want to set these two equal to each other, because we want to have the same number of students willing to go to the college that the college is willing to accept. So we're going to get 20,000 minus 2P, and this is on the consumer side, right? This is consumer demand, student demand of what they're willing to do. When it's equal to the 6,000 plus 0.5p. And notice that's half. 0.5 is half. This is 2. So you multiply by 2 or you divide by 2, sort of the two sides of it. This is the producers. Okay. If we solve for that p, that's going to be the equilibrium. It's where both demands are equal. So there's a -2 here. Why don't we add 2p to both sides? And again, the number that will be different is the 6,000. All the other numbers should remain the same as far as how I know it works. That becomes 20,000 equals 6,000. 2 plus 2.5, right? So that's going to, or sorry, 2 plus 0.5, so that's 2.5p. And then we subtract 6,000 from both sides. $14,000 equals 2.5p. And if we divide both sides by 2.5, that will be the price that gives us both. $14 divided by 2.5, 14,000. 5,600. And again, that's a price. So if we charge a tuition of 5,600, demand's going to be at an equilibrium. And what we could do is we could plug this 56 into both of these equations, right? And we should get the same number. That's what we're saying, is that these both are going to be equal. But what that gives us, so we could plug it into one or the other. You don't have to use two, but you could, you know. Once we plug it in, that's going to give us the demand, the Q bar, because this is really P bar. It's the equilibrium one. It's the one we would set it at, okay? And so take either one of these. Let's go ahead and take 20,000 minus 2. We're going to plug in the P, 56. And so we get 20,000. Oops. Too many zeros. Oops, not that. 20,000. 2 times 5,600 is going to be 11,200. And so that means, it's what, about 9,000 something, 8,800? 8,800. So that's the number of students, that's the demand, that's the Q bar that we should get. Okay. And then for the consumer, right? And I'm not going to solve all the way, but this is a step you're going to need to do that we haven't really talked about until now. To get the consumer surplus, what you're going to need to do is remember that's this minus P bar. So it's going to be 20,000 minus 2P minus P bar, which is 5,600. Actually, let's move that down. Okay, so for the consumer side, let's go down here. We're going to get the integral from 0 to P bar, Q bar, 8,800. Maybe we should write that up here. The general formula, 0 to Q bar, D of Q minus P bar, dq. So just put all the D of Q is, this is actually D of, wait a minute. This is D of P, we need D of Q. So in both cases, since we've got Q equals this function with P, we need to plug it into the formula. Since we need D of Q, we need to plug in the Q to get the P. We have to solve it for P. So again, it's going to be Q minus 20,000 equals minus 2P, divide by negative 2. So P is going to be Q minus 20,000, all divided by negative 2. And you could simplify that if you want, but that's going to be your consumer function. Times, oh wait, Q, no. That's your consumer function, and then you're going to subtract P bar, 5,600. And I'll let you go ahead and either simplify this somehow. You get 10,000 minus this, so it's not too bad. That'll give you your consumer surplus. You'll do the same thing for the producer surplus, except again, you're going to have to solve it for P, but just remember on the producer side, it's going to be P bars, we're actually giving a little bit extra, minus the demand function of Q. And again, it goes for the same period, so it goes from 0 to Q bar, 8,800. DQ. So I'll let you set that up. And again, we've got this function up here, but it's with P being plugged in to give us Q, so you need to solve it for P. You need a P equals, okay? Because in this case, for the producer, P equals some function in terms of Q, S of Q. And that'll give it to you. And what you'll get is you'll get both a consumer surplus and a producer surplus. So that's the total amount of money left in the economy, because students were willing to pay more. The college was willing to accept those students, some of those students at a lower price, but they're getting more. They're getting an average price, and so that's the concepts in there. Okay, that's what's going to ask you. But the main part of this one, so all the first 5 problems, they give you a function, and they'll ask you either for consumer surplus, the first, I think, 3 of them. Then there's 2 questions that ask, 2 or 3, that ask about producer surplus. So those, again, just switch it. And this last one sort of asks for both of them, but it also asks for that equilibrium price. Okay, and this is, I just copied it, so it's the same question. The only thing that's going to be different is this number 6,000 will be potentially something different for you. But got it enough to get it set up. See how you do with it. There's only 6 problems. Remember, for the final, we're limited in number of questions. There might be 1 question. And once I do know, I'll let you know whether it's a consumer surplus or a producer's surplus. It'll be one or the other. I don't foresee it being one of these ones, but if it is, I'll let you know that too. Because I don't write the finals, but I would have one or the other. And once you get working through them, they're pretty simple. As long as you stick with what is P, what is Q, and you don't mix them up like I did. And I remember that was the hardest part when I took this class 30 years ago or 40 years ago. Jeez, it was 40 years ago. That was the problem I had with it. All right? You see, that was the last slide. Any questions? Yes.
So when you're taking the demand equation and you're solving for P
Uh-huh.
right there, that's giving you the quantity demanded?
It's giving you sort of, demand functions are, you input the quantity and that gives you the price.
Yeah.
So, but they're doing this, they're always doing this, you actually set the price and that gives you a certain quantity. So you kind of have to go both ways with this, but the function for calculating either consumer surplus or producer surplus are based on having a function where the input is the number sold, giving us the price.
So it's kind
So
of
they're,
opposite kind of?
yeah, it's opposite. So
So even though it's asking for like in the consumer surplus equation,
uh-huh.
it's asking for DQ, you actually want to solve for Q at any given price, right? That's basically what you're doing there.
Well, the DQ, you want to set the price.
Yeah.
So it's just that the original function they gave us sets the demand. Yeah, it does that for us, sort of. If I have this price, it will tell us the demand. But to integrate, we want the function that if you know the demand, it gives you the price. And so that's why we have to make sure that the function we're working with is solved for P. P equals Q is the function that, right. Q, so we want P, because this is now the demand function at Q. Okay. Initially, it's much easier to work with a function that has P and equals Q because we just plug in the price they give us. We can find that price. And that's, in reality, that's what we do. We set a price. Oh, it gives me this much. If we don't like that, we change the price. But it's the price we set will give us a certain demand, right? A certain number of sales. But then when we go to get that, how much surplus, we have to get the function. We need the function, sort of the inverse. We need P equals some function of Q. And then that's what we integrate. Is that making? It's, yeah. Basically, if you remember, just for the integration part, we're going to, that while it's helpful to have it in this form, because when I get P, I just plug it in and that gives me Q. When I'm going to integrate, I don't integrate this because I'm integrating DQ, right? I need a derivative function that has a Q in here, so I have to solve for P. And then I got some function like here that has math being done to Q. So just kind of remember that. And what I sort of work from, I mean, I went from, is if we go back to the original, you'll see either for surplus or the other one, the function we're integrating is a function with Q plugged in giving us P, right? Let's see. So it's kind of like, just look at this. This is a function where P equals S of Q. Q is the input, P is the output, is the way I remember it. Okay, and so if they give me a function that Q equals something 3 times P, I need to solve it so that it's P equals Q divided by 3. Because this is not S of Q, this would be some function of P.
Oh, okay.
Right,
So then it gives you Q equals something that's not actually S of Q.
Yes.
Okay.
So then I want to change this and say, okay, Q divided by 3 equals P. This is what I want to use. This is my demand function now. But when you're solving for P, this first one's easy to use. So we use them both, but the one that ends up being integrated is the one that has the math being done to the Q. Okay, And I think once you work through a few of them, you'll see. Let's go back enough. See, where did they give it to us? Yeah. So I would, this once I have the box around, I would write that down and then just kind of remember yourself, and then and had I did that, I probably wouldn't have made that mistake that when they gave me the price, if I would have written down that's P equals, I wouldn't have plugged it in for Q because I was moving too fast. Okay, so if you put this down, you can, okay, Q, that's demand, P is the price. So when I'm looking for it, like on the next one, so this one they gave it P equals, but if they would have given us Q equals something, we would have had to solve for it. Okay, and then they gave us a price, so we plug it in, and again, had they given it to us in the other form, plug in P and we get Q right away, that's actually kind of nice. But this one's nice because now we've got the function that we need to use, right? Input Q and go from there. So just and I think you'll follow, I didn't look at them real closely, but usually in consumer surplus, they'll give you the function in this form where P equals, so it's ready to go. But then they'll give you P and you've got to solve for Q. So there's still that work you've got to do. And then usually for the producer's surplus, and again, there's I think only 2 questions that do producer's surplus, they are more likely to give you a function that is Q equals P, and then you're going to have to solve it. But this one's, the first part's easy. When they give you the P, you just plug it in and you get the Q, right? But the function you're going to use, you've got to solve for P, so that you get P equals some function of Q. And when they do that, so this is the function that we're going to integrate. Okay, so that's usually going to happen with producer surplus. Okay, but just, and that'll be helpful. Questions? Or again, there's 6 questions. Work through it. As soon as I have a feeling or communication on what's exactly going to be on the final, which should be coming relatively soon because we have to get them printed and all that kind of stuff, I'll give you more updates of what to focus on. But at this time, I kind of go through this stuff, maybe work a few of them, see it, but also start the review process on anything that you and again, you decide what works best for you. If you want to keep what you did well at, you still want to do well at it, but you also want to pick up anything you didn't do so well at, because that would impact your lowest scoring test, right? And again, you see in Canvas, I have the solutions for them. So even if you haven't picked it up, you can kind of look over those and maybe you remember how you did it. If you want them, just send me an email. I'll make sure I have them with me, or come to my office hours, and I'm happy to give back all the exam 1, 2, 3 if you don't have those. But they're also the solutions, at least, are in Canvas. And then we've got one potential more assignment on Tuesday, but again, hopefully by then I'll know whether it's even on the exam or not. And if it's not, we'll just do it. And I'll focus on just the part that is going to be on there so that we can start into the review a little bit. So by Thursday we can have let's work some problems that you hadn't seen. Because remember, this is like a whole semester of stuff. And then we got the finals week. We don't see each other. We don't meet the Tuesday of finals week. We only meet that last Thursday, May 4th, to take the final. And we won't be here. We will be, I just want you to see, we're in lower level 71. We're in this building but not this room, location and time.
You're on this floor?
I think so. It's L74, which I think is L1. So this is lower level 1. 74 is probably one of these down here. But I haven't found it myself, so I'll look around, but next time I'll verify it. But that's, yeah, we're in this building, L174. This is L120, so I'm assuming it's way down at the other end. But on this level, I would assume. Okay. Thank you all for coming. We got time for questions if you want. You can head out if you want. Oh, I guess we don't really have